Good afternoon, friends. We continue our podcast series about technology and specifically about television technologies. And today, in this video, we're going to talk in great detail about the misfortune that struck us in the early 20s, namely remote work and everything related to these remote technologies and its implications on our daily lives and work environments. And perhaps one of the most important discoveries of the remote lifestyle, as well as remote production and everything that comes with it, are the challenges and opportunities that have arisen from this shift to remote work and technology. How exactly do you transmit that very video in order to play it in the studio, to receive feeds at home, and so on and the like? Today we're going to talk about one of the technological solutions, the implementation of the SRT protocol. And I'm happy to welcome my guest today, and this is Alexandre Gritsouk. Alexandre is a top expert in video transmission over the public internet. And today I'd like to ask Alexandre a few questions and, together with you, figure out what protocols actually are. Let's start with the most basic question. What exactly is the protocol? SRT. Why is it so popular, and what's the reason for that? The main differences from all other methods of video transmission, and in general, any kind of data transmission over the public internet. Please, Alexander.
Good afternoon. Yes, that's a big question. Well, let's put it this way. SRT, depending on who we're talking to, can be explained in different ways. If it's a technical specialist, who I hope is familiar with IP-related matters and knows what the TCP and UDP protocols are. It would be great if they already had experience working with classic TS over UDP, RTP protocols on one hand, and RTMP or HLS on the other. For such a person, the explanation would look like this. SRT is a UDP-type protocol for video stream transmission that has a return channel added to it. This allows, within the designated channel delay and buffer, for lost packets to be resent in time. The lost packets can thus be added to the queue in time and successfully decoded without loss. And if we're talking with management, with people responsible for finances, performance results, procurement, or possibly producers, then for them, SRT is a protocol that enables significant savings in operational expenses, simply by abandoning classical technologies such as satellites, ground-dedicated channels, or give them a chance to come up with new business ideas and concepts in the media industry where you can already ignore the cost of this delivery since it will become negligible if you apply SRT protocol. That's more or less the explanation of what it is, right?
Well, once we start talking about finance people, producers, and the rest, they'll immediately jump in and say, "Dear friends, that's all well and good, but in reality, of course, guaranteed signal delivery lines are very important. And what you're planning to broadcast over the public internet will undoubtedly be of lower quality. If it's not up to standard, it won't be possible to put it to a program feed. In general, you simply can't rely on it. There's a common belief that anything transmitted over the public internet is much worse than over dedicated lines."
In terms of picture quality, you mean? Of course, yes, I'm not ready to speak for all protocols. But for SRT, sometimes I hear conversations like that. It doesn't seem quite applicable, as the video quality such as used codecs and encoding parameters, all this is not described in the protocol. SRT is actually an IP cover. And of course, if you send an H.264 transport stream inside the SRT, for example, at 4 megabits per second, using basic encoding profile, you will get low-quality picture, which is not good enough for many tasks, although it can be acceptable for some applications. But you have the options how to encode with the H.265 codec at an insane bitrate, say 80 megabits per second, apply profiles, 10-bit 422, do all of that, add B-frames, and you'll get a stunning, completely different image as a result. But both options will be transmitted over SRT. Let me give you a very simple analogy. If you build a new water pipeline, clean, modern, with high capacity, but you're supplying water from a pond, then that's exactly what you'll get at the output. It's pointless to blame the pipeline for doing something to the water. It's the same with SRT. The question is, what did you encode and package into it?
All right. In simple terms, we've got a general understanding that the protocol is indeed good for transmitting quality video. More precisely, whatever you put into it, it will deliver. But when it comes to this kind of statement that yes, indeed, we put something into the protocol and it delivered high-quality video, it's always about latency. Well, because we understand how physics works, we know what it means to transmit over the public internet, through an unreliable environment, and so on and so forth. And very often, in many cases, latency is absolutely critical. In fact, it can be a complete deal breaker for certain critical applications like live news broadcasts or sports, or, God forbid, for betting. These are exactly the kinds of applications that are extremely time sensitive when it comes to receiving the signal. From this point of view, is the SRT protocol better or worse? If it's better, then in what way?
Look, yes, SRT. I already mentioned that its main mode of operation is that it restores video by introducing a delay. And indeed, in the video industry, this is a very important issue. But let's take a few examples for reference. Everyone is familiar with satellite channels or backpacks that operate via cellular networks. These typically have a delay of 1 to 2 seconds, which the industry is used to. Even in live broadcasts, this technology is used successfully. In the same direction, we can take existing RTMP, HLS protocols that already give many seconds or even tens of seconds of delay. And on the other side, if we're talking about IP, of course, there's the classic TS over UDP, which also has a delay, the physical time transmission of a packet through the channel from point A to point B. How long it takes for the packet to travel, that's how long UDP will take to deliver it. That is basically the minimum delay, unless we start getting into the details of the speed of light. Now, for SRT to work reliably, there are usually recommendations for the buffer, of course with various nuances. But this is the general idea. You'll need to multiply round-trip physical delay in the channel by 3 or 4.
If, say, it's between Europe and, let's say, America, if we have round-trip delay, a physical delay of, 300 to 400 milliseconds, then you need to set the delay to 900 milliseconds to 1 second, and everything will work fine.
Exactly right. You'll get a stable channel. Here's a real-world example with a smaller delay. If it's a link between Astana and Almaty, for instance, you might have around 20 milliseconds of physical delay. Just estimating here. So even at 100-120 milliseconds, it will be a fully stable and functional channel. That's about 5 to 6 frames of delay, but you're essentially transmitting professional video over the public internet at virtually no cost. That's the kind of delay we're talking about. I think the main takeaway is that it's under a second, even over the longest distances. That's better than satellite or any backpack-based technologies. And of course, you can set higher delays if that's not critical for you. You'll simply gain a greater margin of channel reliability.
Let's return once again to the topic of quality. There's a common belief, and at one point it even briefly appeared in the industry press, there was information suggesting that SRT has bitrate limitations for transmitting useful content like video and audio, or anything else for that matter. Are there currently any limitations that could significantly affect the bitrate and accordingly the quality of the signal?
No, there are no limitations, but I know where that story comes from. Back in the early days when the first public releases of SRT came out, the protocol had a specified default bandwidth limit that SRT could use within the total bandwidth, and it was set to 100 Mbps. The protocol developers quickly realized that no one reads manuals here, as usual, whether it's for a mixer or the SRT protocol. So they changed that default limit to 1 gigabit per second. So that's where the story ended. I think the main limitation you'll face when transmitting video over SRT is your actual bandwidth from your provider. Gigabit ports have been available for a while, and at professional locations you can get 10 gigabits per second or more. Those are essentially the theoretical limits of your links, but in practice, most people still use the 6465 codec with SRT nowadays. That, of course, is much less than 100 megabits. I can give an example where multiplexes are converted into SRT and packaged. In those cases, the bandwidths can be quite large and it works perfectly. No issues.
Well, yeah. Since, once again, we're talking about transmitting extremely useful data, specifically video signals, news segments, or live feeds, over an unreliable medium such as the public internet, mobile networks, or anything else, the issue of packet loss inevitably arises. We just touched on the idea that having a buffer of 3-4 physical links would be beneficial, say for 300 milliseconds to about a second. But if we talk about the quality of the channel itself, because, well, if we consider, for example, during large-scale events like major sports events, where everyone is taking photos, sending pictures, short videos, and so on, using mobile networks is always very unreliable, and there's a high rate of packet loss. And again, there's a common belief that the SRT protocol was designed for corporate networks where such high packet loss doesn't occur, and it can realistically recover around 10-15% of lost packets. And this limit, again, as I've heard and discussed, is generally acknowledged to exist. And they say that indeed, with more than 10 to 15% packet loss, the SRT protocol won't be able to recover. Is there actually any truth to this? Are there physical limitations, or is this speculation from malicious competitors?
Yes, it's just speculation, I think. It's not entirely accurate to say that there's a specific percentage loss limit that a given protocol can compensate for. But specifically with SRT, because it naturally depends on what buffer duration you assign, how much time you allow for retransmission requests, and what additional bandwidth you have available in the channel, since it's within that bandwidth that the retransmission requests will be sent. So of course, there's no such specific numbers like 10-15%. It all depends on your settings, and we're talking about completely reasonable settings. So we have many cases where the losses are much higher. SRT handles them perfectly. And I think it's worth making a remark. It's a bad situation when you have more than 50% packet loss in the channel. Just imagine when there's a retransmission request for packets lost in the previous exchange. Then half of those get lost again, and so it just...
Well, it accumulates, and then the buffer gets clogged, and all the stuff we love. Retries and packet loss, right?
Yes, I think I'll make one more remark. Of course, when you start and configure an SRT session, you need to plan for the worst-case scenario. Since you can't seamlessly change the buffer size in the middle of a session, you have to account for the worst-case scenario from the start.
And this buffer, can the amount of packet loss be measured somehow at the beginning? Before setting up the stream or before starting the transmission? Is there a way to measure it, see it, and correctly set the delay, buffer size, and everything else? Is there such a toolkit?
Yes, such a toolkit exists in professional SRT solutions. This is when, on the receiving or sending side, or both, you can open it in real time. A graph of the SRT protocol's operation, where you can see the buffer, how compensation works, what losses occur, on average, accumulated, how many packets were compensated. This is generally available in professional solutions. If it's not a professional solution, then people usually set it
By
eye with a large safety margin. This works in most cases. It's just not optimal in terms of minimizing latency. If you want to have minimal latency, then you need a tool that shows you what's happening in the channel, of course, and then you can adjust accordingly.
Interesting. Is it really possible to somehow create an automatic delay or automatic buffer size that would be ideal, of course, a no-brainer, just press a button and it measures everything itself. The channel would say something like, guys, you've got 2.5 seconds here and everything will run smoothly with 99% probability.
Yes, that's a common question. You're absolutely right to ask it. And it's been discussed with the developers many times. They respond, I think, quite reasonably that there's not much point in implementing that in the protocol. This is a functionality that can already be implemented directly within an SRT-based solution. So in this solution, you should have a window where you check a box for automatic delay or buffering. It measures everything, just as you described, and sets a reasonable delay. And such solutions do exist on the market. Each manufacturer decides for themselves whether they want to include this feature or not. The only downside one could imagine is if your channel has fluctuating delay. In that case, the system might make a mistake and issues may occur during the session. You just switch to manual mode and adjust things. Make the necessary corrections.
Well, I just wanted to add a comment from my side that we actually built these during our project. Back in February of this year, during the Games of the Future, we actually handled all the distribution using the SRT protocol, and in general, we never encountered a need to reconfigure the delay, or issues like packet loss and so on. Overall, it was quite convenient, and as we know when it comes to connectivity, if no one mentions the connection, it means it was good. Basically, no one mentioned the connection, so there were other issues, but not these ones, which is already a good sign. Tell us about some other interesting features implemented in the SRT protocol that clearly set it apart from the rest.
Let's go over a couple technical ones. It was very smart to include this from the beginning. Channel security. Since we're talking about public networks, of course, everyone is concerned about content security. So AES, which you can easily enable. Without the key, you can't open the stream.
AES encryption, got it.
Secondly, there are a lot of questions about this. People who are used to UDP don't immediately realize that SRT has a really cool feature. It can initiate a session